Hey everyone, this is Master Channel here, and today we're going to be going through continuous probability distributions. The title, I'm aware that the title says Bernoulli trials, and that's actually just a quick recap of what I sort of missed in the other episode. But anyway, yeah. So a Bernoulli distribution is the in best terms the simplest discrete probability function. That means you have two outcomes of fixed probability. So it's like if I have a coin, okay, I have a coin, and it has two outcomes, so heads or tails. So I can think of this as heads or not heads. That's where you get, so probability P, heads, probability P, not heads, so 1 minus P. That's what you get here, probability X equals X. So P if X is 1, so it's the heads, and 1 minus P if it's X equals 0, so tails. And that continues on the previous episode, on the previous video, and from that we'll just be moving on. So here, next is a continuous random variables. So this is a value that has within a range. Things like a person's height, weight, temperature. Discrete is, not discrete. Continuous is usually something like with a decimal. So discrete is like I have I know 2 coins or something, because you can't really have half a coin in that sense. But if I have like a weight, I can have half a gram or that sort of thing. So it's meant technically not correct, but for the purposes of video, this is usually a good enough explanation. Okay, so here we're going to talk about what's called a probability density function, and I'll put this here. But yeah, so that's just the video there, picture there, and this helps out. So you can imagine this graph here. You just picture this graph, and it's sort of smoothed out, so that as a curve, that sort of thing, and yeah, it looks a little bit more like a function. So here, so probability density function. Sorry about the camera. It helps out when the probability is not currently on the graph. So if we can sketch this out, make this into a curve, the rectangle, left end rule and right point rule that we've done earlier, it can help make it look like a curve and look like a function. And that function can be expressed as a probability. So like for example, actually I'll go into that later. But yeah, so we need to know that okay, no I can't. Okay, so note that x is a variable. And if it's x, so between probably a and b, so it's in the interval here, a and b. So think of a as a point on the x-axis, b is another point on the x-axis. So it's like how we integrating before. So yeah, so you have a to b f of x dx. So here it says f of x has to be greater than 0. So intuitively, if you have a probability, say if I want to have, what's the probability of getting 3 of whatever heads, you can't have a negative probability. That doesn't make sense. So yeah, that's why it has to be greater than 0. So the whole thing, so if I integrate this whole thing, it has to equal to 1. It's a probability, so if I add all the probabilities together, it should equal 1. Then that's just always, I think, yeah. Here, quick notation that probably a get to b to a to x and b, these two are the same thing for these purposes. Yeah, so moving on, and same thing here, similar thing in the bottom here, x less than c, same as less or equal to. And you can write it down you can work out using this form of integration here, and we've sort of covered that through the properties of integration before, where x is subset a and b, c is between a and b. And the last thing is that for a function, usually for a probability density function, the integral will be between -infinity to infinity. That gets you the value of 1. However, because we said here AB has equal 1 is a must. It means all the domain is R, but the rest of the values is 0. And yeah, that'll be all.